Welcome to another lecture on Java. We are going to look at exceptions and errors. And these are the topics we are going to be looking at under exceptions. So types of exceptions. But before that, we want to explain what an exception in Java means. So in Java, an exception is an event that disrupts a normal flow of a program. And that exception, and those exceptions are divided into two: checked exceptions and unchecked exceptions. So checked exceptions are the kind of exceptions that as a developer we can recover from. And these kinds of exception has to be handled by a developer. And all exceptions that inherit from exception class are checked exceptions, except for runtime exception and all its subclasses. Then we also have unchecked exceptions. These are exceptions that we can not recover from. And these kinds of exceptions are not required to be handled by a developer. All exceptions that inherit from runtime exception class are unchecked exceptions, as well as a runtime exception itself. So exception hierarchy. So we see that at the top of the hierarchy we have object, then we have throwable, which is below it. Then under throwable we have exception and error. And then under exceptions we have runtime exception, we have IO exceptions, and then we have all those sub exceptions that we see. And then on the other hand, on the left we have error, then we have under error we have out of memory, stack overflow error, then we have all other exceptions, other errors that follow the hierarchy. So you can actually go to the Java docs to look at this hierarchy yourself. And so now, catching exceptions. So code can handle an exception in Java, or if it doesn't want to handle that exception, if that exception is checked, it can declare that it throws that particular exception itself, in which case now it's delegating the caller of that method to handle that exception itself. And then how to catch an exception. This is the code on the slide, how you can catch an exception. Then rules for catching exceptions. If the exception specified in the catch block is a subclass of exception class and is not a runtime exception, then the try block must have code that can potentially throw that exception or its subclass. Let's explore what that means. So if if this method say throws let's start with exception so that the explanation would be much clearer. And then you are catching this exception. You can just say exception E, then you call print. Okay. So here we can just say x dot print stack trace. So as you can see here, this method it can potentially, actually it throws a exception class, which is an exception. If you call this method, since exception class is checked exception, either you have to catch it or the main method must declare that it throws a checked exception. But now, if you are throwing a runtime exception, you're not required to catch that exception. It's not a requirement. Observe another thing here, that this code, this try block here, it catches an exception class, but there is no code that can potentially throw exception class in the try block. That is what we mean in the slide, and then I'm going to explain it later. If we change this exception to another checked exception, we are going to get a problem. Let's start with throwable. Let's start with, actually it has to be subclass of exception class, that is a checked exception. That's where the problem is. So for instance, if we have IO exception, we have a problem. Why? Because the try block does not have code that can potentially throw IO exception. This is a rule that is very important to remember, especially for those maybe who are preparing for a Java professional certificate, that when you have this scenario, if maybe it's a file not found exception, it's the same thing. Any exception that is checked, that is a subclass of exception class, if you declare it in a catch block, the code in the try block must potentially throw that particular exception. Or maybe it's subclass. So for instance, if we have IO exception here, you can throw new IO exception. This is perfectly allowed. Or you can throw file not found exception. Why? Because file not found exception is a subclass of IO exception in the hierarchy. So this is allowed. This is the rule number 1. Rule number 2, you can have multiple catch blocks. Sorry, you can have multiple exceptions in a catch block defined. So you can have, let me just use runtime exception as a demonstration. You can have runtime exception. You can have okay, this is a bad example because of something I want to explain. Let's start with illegal argument exception. You can also have null pointer exception. You can declare them like this. This is perfectly fine. But you cannot have you cannot have runtime exception here. Why? Because null pointer exception is a runtime exception. So you cannot ideally have a parent exception and a child exception declared like this in the catch block. Either you can have same parents, same children in the hierarchy or different, or maybe here you can have IO exception, but as we remember, we must throw an IO exception here for our code to work, and the code will be fine. That is that rule. Then the other rule is that there can be multiple catch blocks, but the more specific must be thrown first. So this means that if you have a case where you're throwing multiple, you want to separate your catches okay, let me we already have it. We have it like this. Let me just use runtime exceptions. Yeah, it's complaining because this exception is not caught. It must be caught. So if you have this scenario, this is fine. But then you cannot have it the other way around. You cannot have runtime exception and then have null pointer exception. Why? Because null pointer is more specific and runtime is general, and null pointer is a runtime exception. So the more specific must come first, always. So you must have it like this in the hierarchy. That's the last rule. Then exception propagation. Exception propagation in Java occurs when an exception is thrown from the top of the stack. And when this is not, when it is not caught, the exception drops down the call of the stack of the preceding method. If it is not called, it further drops until it reaches the method that initiated the call. So what this means is that I'm just going to run this code here. As we can see that we don't even need to have this. We are calling print call console, and console throws an exception. So this call method call in the stack, it will be on top of the stack. So basically, if this was a stack, okay, if this was a stack, you will have console, you will have print, you will have main, and the stack will execute, code will be executed from the stack. We know that the stack is last in, first out. We'll execute this, come here, and then come here. That's what we wanted to demonstrate. So now we see that console will be at the top of the stack and it throws an exception. But in console, we are not handling this exception. What it will do, it will propagate back to the caller who called it. And who called it? In this case, it's print. We find that print also does not handle that exception. It propagates, it sends it back to the caller. And who called it? It's main. Hence, we have what we call the stack trace. Let's run this code and see the trace. So we see that on top we have console, we have print, we have main. But let's assume that print was handling the exception. Let's just say exception E. Then let's swallow that exception. we will notice that now the trace will be different because the exception was handled in some stack frame or stack frame in the stack trace. So let's see. If we run this code, we see that this was handled. Therefore, we don't have the stack frame because this was handled. But now, let's assume that we again throw that exception here. We throw E here. Let's observe what happens now. We see that we have runtime exception. Okay, let's say new runtime exception. We swallowed that exception because we dealt with that, and we throw it again here. We see the stack frame is now different. Exception was thrown in print and it came to main. This is how the exception propagation actually works. Then overriding methods that throws exception. So you be very careful when you're overriding method that throws an exception. Let's see a demo of what we want to demonstrate here. So assuming that we have interface X, then we just have a void method, void X. This void X throws exception, and main implements X. So we can remove all these methods that we have here. So obviously we have to override that method X. We see that when we override this method, we can specify the throw clause. Another rule that you can do is you can decide to completely remove the throws clause. You are still overriding the same method, but you no longer care about the exception. This is allowed. Or you can throw this exception. What you cannot do is to override that method and throw a parent exception. For instance, if we throw throwable here, we are going to have a problem. But we will see the rule, the change in this rule. Let's say here we are throwing runtime exception, and then here we throw null pointer. You see that for unchecked exception, that rule does not apply. But for checked exceptions, that rule is very critical. If the method in the subclass throws a checked exception other than exception class, the method in the parent class must be the same checked exception or the subclass. So in this case, if we put throwable here, this will work perfectly fine. If we put exception class here, and then here maybe we put runtime, this is perfectly fine. You can override that exception with its, the throws can specify a subclass or a covariant type, a subclass of that exception. So let's see, if we are to throw an IO exception here, this will still work. But now, if we put runtime here, we are going to have a problem. When a checked exception is involved and it's not an exception class, you only have two cases. Especially if that exception is in the subclass. The one that is in the parent class must be the same type or the parent. So if we put exception here, that would be fine. If we put IO exception, that would be fine. If we put throwable, that would be fine. Let's put the file not found exception. That would be fine. So here we cannot put runtime. The one will not work. We have to put IO exception, or we can put exception, or we can put throwable for those checked exception. But for runtime exception, there is no rule. Then stack trace. We have already seen what a stack trace looks like. Then common exception. We have exception class, which is the second in the hierarchy after throwable. Then we have runtime exceptions, which we mentioned that they are unchecked exceptions. Then we have number format exception, which is normally thrown when the format required for numeric whatever manipulation is not correct. Then we have arithmetic exception. So arithmetic exception is thrown in, let's say you are trying to do something like this. Int I equals to 1 divided by 0. Let's run this code. This will give you arithmetic exception, division by 0. Then we will have in array index out of bound. It's when you are trying to access an index that does not exist. Or then you have illegal argument exception. So normally if you want to protect your method from parameters or arguments, if the user has to provide arguments to your method and you want to protect your method from illegal argument, you can specify, you can throw an illegal argument exception. If maybe whatever the user is giving you is not what you're looking for, maybe the range is outside the range, or the type is not correct, or the location, whatever the case might be. Then we have IO exceptions, which are normally thrown when you are dealing with files. You are reading from a text file and all that, and many other exceptions. Then we have class not found exceptions. So this exception occurs when the JVM tries to load the class, but it cannot find it in the class path. So let's see that with an example. Class not found exception. So let me just clear the console. Let's compile this class. This is fine. As you can see here, we have class not found exception, class file generated. So if I run this class, this is perfectly fine. We don't have exception. But let me delete this class file that is generated. You see, we have class not found exception. The JVM is trying to load the class file for this class not found class, but it cannot find it in the class path. That is that exception we are talking about. Then we have errors. So an error is a subclass of throwable, as we saw in the hierarchy, that indicates a serious problem that a reasonable application should not try to catch. Most such errors are abnormal conditions. A method is not required to declare in its throws clause any subclasses of error that might be thrown during the execution of the method, but not caught, since these errors are abnormal conditions that should never occur. An error and its subclasses are regarded as unchecked exceptions for the purposes of compile time checking exceptions. Then we have another type of error. It's called no class definition found error. So this exception indicates, or this error indicates, that the JVM looked in its internal class definition data structure for the definition of a class and did not find it. Permanent generation, PEMGen, where it stores the metadata, did not find it. The required class was available during compile time, but is missing at runtime. Let's demonstrate this as well. So we have this scenario, no class definition found error. All we are doing here is we are just printing hello world, and we are creating this on the fly. So for the purpose of understanding, we can just leave it like this. So what we now want to do is just clear the console. We want to compile this class. Java, no class. It's fine, let's run it. No class. Everything is fine. But observe what happens if I remove A. A is moved. Let me run it again. You see, we have no class definition error for A. It means at runtime, we executed this fine. We had no problem. But now when we came here, we have this, we want to create object A. Then we are looking for class definition A, but we can't find it. Then we are throwing this, no class found error. And we see that this was caused by class not found exception in the stack trace. Then we have another exception called exception initializer error. So this signals that an exception or an unexpected exception has occurred in a static initializer. Is thrown to indicate that an exception occurred during evaluation of a static initializer or initializer for static variables. So let's see what this means. Okay, we can just remove this for now. And then we can remove this. In our previous slides or lectures, we explained what a static initializer means. So let's say we are throwing just runtime exception here. Static. All right, so what we can do, we can call a method here. And this method can throw that exception for us. Purpose of demonstration, we can say throw new runtime exception. All right, so now this guy is not aware that this method is throwing an exception. We just outsmarted the compiler. So what we need to do now is to run this code. See, we get exception in initializer error, because now when the static initializer tried to execute, it found that an exception occurred. This is where we get actually that exception. Stack overflow error, thrown when the stack overflow occurs because an application recurses too deeply. Let's see what that actually means. So let's just do nothing in here for now and remove our static initialize, and then we call print, and then let's make it a recursive function. that does not end, no conditional condition, we see that we end up with a Stack Overflow error because we keep creating many stack frames infinitely. So this method is executing infinitely until the stack is overflowing. Then there is another thing with exceptions that I want to highlight. I believe it was added in Java 7. Try with resources. So try with resources, you are allowed to do something like, you can say try, then in here you can have what can we do? Okay, maybe let's say input string. And let's see who implements this guy. Okay, maybe we can use buffet reader. Buffet reader, new buffet reader. In here we can put okay, buffet reader accepts. Okay, let's see what it accepts. It accepts a reader. Okay, who implements the reader? Let's check. Okay, file reader. So let's see. So basically we can have new file reader in here. And then I believe here we can have, is this a class? It's a name, okay. Then we must have a catch here. We can just say exception for now, E. We have catched this exception. So normally we would do something like this. This is try with resources. We can, instead of declaring it like this, we can put it here and say file reader fr equals to new file reader. Then in here we put fr, and then we separate them like this. Or what you can do, we can put it outside here, and obviously the issue with throws now. Fr, you can say that this guy must be final. Just go in here. Okay, let's not do it like this. Yeah, so if you have this case, what I want us to stress with try with resources is that whatever you put in here, it must meet a certain condition. For instance, I cannot all of a sudden say main main equals to new main. This is not allowed. For it to be allowed to be in here, it must implement auto closable. Then as you can see, it works. Then when you have this, the reason this was added was because they wanted to have a situation whereby you use this close method to close all the resources that needs to be closed for you, without having to, in those days where you are dealing with connection. Say for instance, you have connection cn equals to new, maybe we can say driver manager dot get connection. You have this situation. What you will then need to do, you will need to close a connection in here. Let's say you have a final connection cn, and then you don't have it in here, sorry. You have it in here, sorry. We can remove this for now so I can explain. We have cn equals to new, sorry, equals to driver manager dot get connection. Then we have cn dot close. I may have not been initialized, so we have to have it like this, and then remove this final, and then obviously unhandled exception. Okay, so what we need to do here, we can just say throws exception for the purpose of the demonstration. So as we can see, what we used to do before, we have a connection, we instantiate it, and then we close it in here. So to avoid this, because not all developers can close the connection like this, some will obviously forget. So this auto closable, or this try with resources, will allow you to will execute this method automatically for you without the need to close it. Normally you will have it in the finally block, sorry, where you actually close the connection. So for someone who is maybe not that good in remembering that they always have to close their resources, they forget, then the application will have all those connections that are not closed. But now if you have it with a try with resources, as we saw it in the previous, okay, let's go back. If you have it like this, the close method will automatically be called for you. So let's just say cout closed, and then let's just run this code. So what needs to happen is let's make use of cn out. What are we committing? But in a way, the connection must be used, and then after that the close method would be called for you automatically. That's the whole purpose of the try with resources.